you can write this on the top of page 531. We are going to learn a special order for graphing sine and cosine graphs. I call this method DAB-C because the DAB-C part tells you what order you should go about graphing this. Because there's a D, an A, a B, and a C value. And unlike transformations, in transformations we always did stretches and compressions first, and then translations second. But because we noticed some patterns in the sine and cosine graph, we can do this in a special order, which is going to make our life easier, and it's going to make graphing these quicker. If we use the techniques for graphing from transformations, you'd have to take 5 points and do a bunch of transformations, and it would be a bit annoying. So what we're going to do is we're going to describe what each of these things does, what the order of DAB-C is, and then we're going to do some examples to really see how it works. So first of all, in DAB-C, what is the D value? The D value is your center line or your sinusoidal axis. So the very first thing you're going to do is take out a red pen and draw a horizontal line for your sinusoidal axis or your center line. Next, you're going to take your A value, and remember that A helps you with your amplitude. You're going to use that amplitude to go up from your center line to a maximum and down from your center line to a minimum. So your amplitude is going to help you label a max value and a min value. And what we will have done after the A is we will have our y-axis nicely labeled with a maximum value, a center line, and a minimum value. Next, our B value. We have a formula that tells us our period is 2 pi over our B value, so we can use our B value to find our period, and then we'll be able to label somewhere on our x-axis, make a mark for 1 period, and divide that into 4 equal sections. After your B value, you will have your y-axis nicely labeled and your x-axis nicely labeled. Now you might have thought originally that I had the dash in the DAB-C just because if you tried to say the 4 letters in one word, it doesn't sound very good. Maybe the DAB with the dash and the C in there makes it sound better. But no, the dash is actually something important. We are going to use it for graphing. When you get to the dash, it means that we are going to graph our sine or cosine graph with a dotted line. So the dash is reminding us to draw something with a dotted line, and we are going to do the graph without the phase shift. And finally, the C value is the phase shift that moves your graph left or right. The last thing you're going to do is draw your graph moving it left or right. So we are going to graph 2 of these following the DAB-C method to see what it looks like. Here is our first example. We are going to graph y equals 3 cos to x minus pi over 4 plus 1. I scroll up to there, is that okay? Or was anybody's, is that too far? It's all good? So what I'm going to do is, off to the side, I'm going to write dab C. So that's telling me the order that I need to do things. And we start with our D value. Our D value is 1. That 1 tells us that our center line, I mark 1, I take out a red pen, I draw a dotted line at y equals 1. This is my center line. And that is the only thing you have to do. I'm going to put a check mark above the D. That's all the D stands for. Draw your center line with a dotted line and label it. So there's your D value. Next is your A value. Your A value tells you your amplitude, and your amplitude is the distance from a center line to a maximum. So my A value is 3. That lets me go up 3 to 4, down 3 to -2, and label my maximum and my minimum. So your amplitude lets you label your maximum and minimum. That's all you have to do for your A value. Check mark. Your B value helps you figure out your period. And I've got it written right above here. Our period is 2 pi divided by our B value. Since our B value is 2, 2 pi divided by 2, our period is pi. So we use our B value to figure out our period. Once we've figured out our period, we choose a random spot somewhere on our x-axis and mark our period, which is pi. We then take that space that we just did with 1 period and divide it into 4 equal sections. And we're going to have to label all 4 of those sections. For labeling those 4 sections, I find the middle one is the easiest to label first. Because the middle one will be exactly half of your period.
Hi, so sorry to interrupt.
Hello?
Could I have Julian and Callie to the office, please?
I think you have the wrong classroom.
So sorry.
Unless, did someone lie to me? Does anybody go by Julian? Or Callie? So I would label this middle one first because it is exactly half of the period. Then, of the other 2 that are left, I would label the first one because the first one is half of pi over 2. If you take pi over 2 and multiply it by a half, you will get pi over 4. And then, obviously, you're going to have to label the last one, the third one. Once, to label this third one, since you know that one of these ticky marks is pi over 4, you just have to count. This would be 1 pi over 4, 2 pi over 4, 3 pi over 4 for labeling the third one. So the B value, now I can finally check it off. It is probably the most intense one. You have to calculate your period, label your period, and split it up into 4 equal sections. Now that we've got our y-axis labeled, our x-axis labeled, we can do the dash part. The dash part says, draw your graph without the phase shift. What kind of graph is this? This is a coast graph. Where does a coast graph start? And you're going to hear me say this often. A coast graph starts at a maximum. A sine graph starts in the middle going up. A coast graph starts at a maximum. So I go to my maximum and I draw a dot because that's where a coast graph starts. And then your sections say go from maximum to center line. So you can see why it's important that we've labeled a dotted line for our center line, because that helps us get us to this point. Next ticky mark will be at the minimum, back to the center line, back to the maximum. Draw this with a dotted line. And this is what the dash stands for. We draw our graph without a phase shift. Then finally, We need to do our phase shift. This minus pi over 4, this means pi over 4 to the right. We look on our x-axis. Do we have a pi over 4 labeled? Yes. So this is where it's really nice. Pi over 4 is exactly 1 tiki mark. So I'm going to take this point and move it exactly 1 tiki mark to the right. This point, move it 1 tiki mark to the right. This one, 1 to the right. This one, 1 to the right. This one, 1 to the right. Draw a nice curve through each of those. If you draw straight lines and make it pointy, you'll lose a half a mark for the shape of the graph. So it has to be a nice curve through all of those points. And now we have done everything in the DABC. I can check off the C part. This is way better than doing the 5 points and doing the arrows, because the arrows get complicated with mental math because you're dealing with pi over 4, pi over 3, lots of fractions. Chances of making a mental math error are quite big. This lets us do all of it at once, and it's much shorter, so it's nice. Okay? We'll do one more example together. I'll write out dab C off to the side. Now, I often think about the D and the A values kind of at the same time, because they're going to affect stuff on my y-axis. Can you see on this one that your D value is -2, and your amplitude is going to be 4? So as far as when I'm drawing my scale here, I sometimes make this a little bit higher because I know that my center is going to be at -2. I take my -2, I draw a dotted line in red, label it y equals -2, check off my D value. Even though there's a -4 out in front, your amplitude is still +4. Amplitude is a positive number all the time. So if my amplitude is +4, I take my center line, I go up 4, give me a maximum of 2, I go down 4 to -6, and I've now successfully done my A value. Oops. Your period is 2 pi divided by your B value. Your B value is 3, so your period would be 2 pi over 3. Find somewhere on your x-axis, make a mark, label that as 2 pi over 3. Divide it into 4 equal sections. Half of 2 pi over 3 would be pi over 3. Half of pi over 3 would be pi over 6. 1 pi over 6, 2 pi over 6. This will be 3 pi over 6, and you could leave it as 3 pi over 6, or if you wanted to reduce that to pi over 2, that's perfectly fine. So your B value is probably the most involved. You have to calculate your period, label one period and divide it into 4 equal sections, and label all 4 of those sections. Now we're going to do the dash. And in this one in particular, we also are going to notice that we have a vertical reflection here. What does a vertical reflection do for a sine graph? Well, a sine graph normally starts in the middle going up, but can you see if you flipped it? It will start in the middle, but going down instead of up. If you had a negative coast graph, a coast graph normally starts at a maximum. Does it make sense that a negative coast graph would start at a minimum? So when we're doing the dash part, we go to our center line. It's going to start on the center line, but it's going to go down. So the next, at pi over 6, it's going to be all the way down to the minimum, then back to your center line, then to your maximum, then back to your center line. Draw this with a dotted line. This is our graph without the phase shift. And finally, the phase shift. Notice that we have a pi over 6. That's going to be because it's plus pi over 6. That's pi over 6 to the left. We have nothing labeled to the left. But we do know how much pi over 6 is. Can you see that we've labeled pi over 6 to the right? So I could take this exact same distance and go pi over 6 to the left and label negative pi over 6. And I can take each of the 5 points that I have and now move them that distance to the left. This one will move 1 over to the left. This one 1 mark to the left. This one 1 mark to the left. And we can now draw our final graph. Through each of those points. So if you want to try one on your own at home tonight, you can try question 3 or question 8.